Hello students, good morning. Now we are going to see about the gamma and beta distributions. What are gamma and beta distributions? Gamma distribution reduces exponential distribution and beta distribution reduces to uniform distribution. So gamma distribution is nothing but at one particular case it will be same as the exponential distribution. Beta distribution in particular case it will be equal to the uniform distribution. That is some special case it is true. Moreover, gamma distribution is a generalization of exponential distribution in the same sense as the negative binomial distribution is a generalization of geometric distribution. So from the geometric distribution, you can go back to negative binomial distribution. Same way, exponential distribution is nothing but a particular case of the gamma distribution. In a sense, the geometric distribution and negative binomial distributions, these are nothing but these two distributions are discrete. Okay, they are analogous, same to the exponential and gamma distribution. Exponential gamma distributions are continuous distribution, whereas this geometric and negative binomial distribution are discrete distributions, but in the way they are analogous to each other. They are related to each other. You can understand the word of analogous. Right now we are going to see how the beta distribution, what is the function of the beta distribution. Okay, first we'll see the beta functions. In order to see the beta distribution, we should know about the beta function. Okay, beta function. So we'll learn what is a beta function. So what is a beta function? First we'll understand about the definition of the beta function. If m is greater than 0, okay, if m greater than 0, n greater than 0, the integral, that is this integral 0 to 1 x power m minus 1 minus x the whole to the power of n minus 1 dx. This function, this integral is called a I can call it as a beta function, right? Is called a beta function. Okay, and it is having some easy way of denoting it, symbol. Okay, and is denoted by beta of m comma n. Okay, this is nothing but for m should be positive and n should be positive. This integral, what is this integral? Integral 0 to 1 x power m minus 1 minus x whole power n minus 1, and this integral is known as the beta function. Okay, and how it is denoted? It is denoted by beta of m comma n. So I can write it as beta of m comma n. What is beta of m comma n? It is nothing but integral 0 to 1 x power m minus 1 minus x whole to the power of n minus 1 dx. This is nothing but my beta of m comma n. Okay, why we are learning this is, in order to learn about the beta distribution, we should know about the beta function and gamma function. Okay, then only we can understand the beta distribution. So that is the reason we are learning about this. Now we will see some example. The first example is integral 0 to 1. See the limit, integral 0 to 1. Okay, square root of x. Okay, 1 minus x whole square into dx. We are supposed to evaluate this integral. I will write it down here. So we are supposed to evaluate this particular integral. So we have to reduce this into this, we have to reduce this. How to reduce this? In this function, known function, that is integral 0 to infinity, x power m minus 1, 1 minus x whole power n minus 1 into dx. This form you have to reduce. So we will easily it can be done. What is square root of x? Square root of x is nothing but x to the power of half. I'll write it here. Square root of x is nothing but x to the power of half. We want something m minus 1. What we want? M minus 1. Okay? The power m minus 1 is what? Half. What is my m? M will be half plus 1. That is 3 by 2. So x to the power of m minus 1. What is my, this is nothing but square root of x. What is square root of x? X to the power of half. But in the power I need m minus 1. Okay, that is m minus 1 is half. M is half plus 1, that is 3 by 2. So I can write x to the power of half as is same as writing x to the power of 3 by 2 minus 1. Right? So I'll be writing here as, instead of square root of x, I will write this as 3 by 2 minus 1. Okay, same way 1 minus x to the power of 2. So that can be written as 1 minus x to the power of n minus 1. So what is my n minus 1? Is 2. So n will be 2 plus 1, that is 3. So I can write it as, n is 3, no? So 3 minus 1 into dx. So this is my m minus 1, and this is my n minus 1. What is the answer? It's beta of m comma n. So I will be getting beta of 3 by 2 m comma n. What is my n? N is nothing but my 3. Okay, so the answer is beta of 2 by 3 comma 3. This is my m and this is my n. Right? We'll go to the next. One more sum we'll try to solve. Second sum. So second sum, we have to simply reduce this into this beta function. That's it. Very simple. Integral 0 to 1 x to the power of minus 1 by 3, 1 minus x to the power of minus 1 by 3 into dx. Same way, I'll just look into the power. What is my power? Power is x to the power of minus 1 by 3. Okay, so I want minus 1 by 3 in the form of m minus 1, like we did previous one, no? M minus 1. M minus 1 is minus 1 by 3, right? M equal to minus 1 by 3. This only I am taking m minus 1. Okay, this is my m minus 1 power. So m minus 1 is 1 by 3. M is minus 1 by 3 plus 1. 2 by 3. Okay, my m value will be 2 by 3. Same way, I will see the n value. What is my n value? N value is nothing but 1 minus x, okay, to the power of minus 1 by 3. Okay, this is also minus 1 by 3. So what is this? So this is equivalent to my n minus 1. Okay, therefore, what is my n minus 1? N minus 1 is minus 1 by 3. So n equal to minus 1 by 3 plus 1. It is nothing but 2 by 3. So I got the value of m. I got the value of n. So I'll go back to the question. This can be written in the form of integral 0 to 1. Okay, x to the power of m minus 1. What is my m? M is 2 by 3. M is 2 by 3. 2 by 3 minus 1. Therefore, m minus 1. What is 2 by 3 minus 1? Is same as minus 1 by 3. 2 by 3 minus 1 is same as minus 1 by 3. Right? Says, oh, I am doing a small modification, that's it. Minus 1 by 3 can be written as same way, n minus 1. What is my n? N is 2 by 3. Okay, n minus 1. N minus 1 will be 2 by 3 minus 1. What is this? Beta of m comma n. Beta of m comma n. Okay, this is nothing but beta of my m comma n. This is my m and this is my n and this is beta of m comma n. Okay, now we will see properties of the beta function, right? These are the properties of the beta function. The first property is beta function is symmetric function. Beta of m comma n is same as beta of n comma m. Okay, the first property is beta function is symmetric function. Beta of m comma n is same as beta of n comma m. There are some other forms of beta function. One of these forms which will be helpful in defining beta distribution of second kind, but we are not going to see the second kind, okay? Beta of m comma n equal to integral 0 to infinitive x to the power of m minus 1 divided by 1 plus x to the power of m plus 1 into dx. So there are different forms of beta function. This is one of the form. This will be helpful in defining the beta distribution of second kind. Okay, I hope you understand something about the beta function. Okay, this is all about the beta function. And there are some questions for you to solve. It is given in the your notes I have given. Okay, please solve those questions. Next comes the gamma function. What is a gamma function? Like a beta function, there is also a gamma function. Okay, we'll see what is a gamma function. These two functions are useful in finding the beta distribution and gamma distribution. They will be very much helpful. What is the definition of the gamma function? If n is greater than 0, the integral 0 to infinitive, beta is 0 to 1, no? Gamma is 0 to infinitive, and also given that n is greater than 0. Okay, x to the power of n minus 1, e to the power of minus x dx. Okay, this is called a gamma function. What do you call this? This is a gamma function. Okay, and is denoted by, how the beta function is denoted? Beta of m comma n. There are two parameters, and the gamma is having only one parameter, therefore it is only one you will get. It is denoted by gamma of n. So I can write as gamma of n equal to integral 0 to infinitive x to the power of n minus 1 e to the power of minus x dx. And this is known as the gamma function. Okay, this beta function and gamma function both will be useful to us, okay, in beta and gamma distribution, and we will be proceeding in the next class.